Okay, so today's topic is random numbers, and this will tie in a little bit with arrays. So we're continuing on with what we're doing in CS150. So far, our programs have pretty much been deterministic. We follow a sequence of instructions, or maybe some loops, some conditionals. Depending on input, we may take some different actions, but we can always pretty much determine exactly what's going to happen with the program based on the input. If the input's the same, then the output is going to be the same. We might want a little bit more variety because, basically in these deterministic programs, if there's anything that surprises us that may be a bug or a runtime error, that's not really what we want. So it's been not exactly exciting. So how can we make these things more exciting? Well, we can add randomness to the program. And you can do this with random numbers. So this is a guessing game. So they'll generate a number between 0 and 99, and you get to guess what the number is. It'll give you feedback based on high or low. So what we have in the two lines that are highlighted by the arrow is the initial random variable based on the system time. We need to include C time and C standard live to do this. And then the num is that random number modulo 100. So that'll give a number between 0 and 99. If we wanted between 1 and 100, we could add 1 to that. So this is an idea called pseudo-randomness. And computers are designed to execute the precise sequence of instructions. So they can't really generate a true random number. And even if you do, take something like sometimes radioactive decay over very short periods of time is described as random, maybe that we just don't completely understand what that process is. So it's hard to find something that's truly, truly random. So what we can do is we can make deterministic behavior sufficiently complex that it looks random, and that's called pseudo-randomness, and that's how C++ does the random numbers. So we give an initial seed, an initial condition, or a random seed, and with these with this initial condition, it'll determine what the random numbers are. If I give it the same initial seed, then it'll give me the same random numbers, hence why we use that C time as the initial seed. So if we do srand 78784871212, it'll give us a set of random numbers based on that. If we use that same number again, then we will get the same sequence of random numbers. And it used to be back in the early 1980s when you were playing a game and it asked you to give a random number seed, ask the player. And then if you gave the same random number seed, you could always determine what would happen as a result of playing the game. So you would try different random number seeds. But now we have it so that we kind of generate it for you, usually based on the time. And basically, that's current wall clock time, usually in seconds, since 1970 when Unix was born. So CS241 actually covers the way that you do that mathematically, but the command in C++ is rand. And so you can generate a pseudo-random number between 0 and rand max. Usually we don't want numbers in that big of a range, so we need to transform, and we can do that with the modulo operator. So if we want something between 0 to b, we can do rand percent b plus 1. So, for example, rand percent 100 generates random numbers between 0 and 99. If we want a random number range from A to B, we can do it as rand percent B minus A plus 1 plus A. If we need a double in the range of 0 to 1, we can do rand divided by rand max plus 1, and that'll give us a number in the range of 0 to 1. That's also a very common thing that we want to do. What if we wanted to flip a coin? Well, we could do that range between 0 and 1. If it was less than 0.5, it's heads. Otherwise, it would be tails. Or we could do rand percent 2. If it's 0, that would be heads. If it's 1, it's tails. And that gives us an easy 0.5 chance. Now, if we want the coin to be unfair, so that, it might be a weighted coin, then you can have it land on heads 80% of the time. You would change 0.5 to 0.8. Roll of the dice, rand percent 6 plus 1. That will give you a number between 1 and 6. What if you wanted loaded dice? And this is a problem I typically have in CS407 for some of the simulation. 1 has a 30% chance, 2 has a 10, 3 has 5, 4 has 5% chance, 5 has a 30% chance, and 6 has a 20% chance. So this die is loaded towards 1, 5, and 6. It would be rare that you would roll a 2, 3, or 4. So that's what the distribution would look like. And what we could do is we could actually use an array. So the array would be 0.3, 0.1, 0.05, 0.05, 0.3, and 0.2. And basically, we can get that number between 0 and 1 and then see where that number it lands in that probability distribution. So RAND has problems. It's fast, but it's not a great source of random numbers. If you need higher quality or special distributions, there's a pound include random library. The syntax gets a bit confusing, so you may have to look at a source like C++ reference, work through some example problems to see exactly how that library works, but it'll give you a higher quality distribution of random numbers. So random numbers are a lot of fun, and we can do things like generating maps and video games, creating more unpredictable enemies for players to defeat, which is always a good challenge for a video game. Random images, levels, etc. The list goes on. So thanks so much for watching.